Hello everyone, welcome to this presentation about scanning for security vulnerabilities in embedded distributions. My name is Marta, and I have 20 years of experience in open source development, including 15 years in embedded. I do have a PhD in telecommunications, so I do have security backgrounds, and I have worked in different fields like embedded product development and silicon, and now have moved to distributions. I'm contributing to the Neuro project since April 21 while consulting for OSTC. And now a few words about Neuro because it will make it easier for you to understand how we use scanning for security issues. Oniro is a source-based distribution using Yocto and Open Embedded. We are aiming for IoT space and for consumer devices. It means that the distribution is designed for products with a long-term support LTS version. It also means that we maintain packages for years. One important difference between Oniro and other embedded distributions is that we support multiple operating system kernels at the same time. Operating system kernels like Linux and Zephyr, and various device types, as you can imagine, of different sizes and different hardware features. Oniro is an Eclipse project since late 21. So now, why is scanning important for us and important for you? Oniro is a distribution. It means that we get packages from different sources. In a typical build, we do have around 300 packages. Product builds will be probably quite similar, if not bigger. We are aiming at IoT devices, what means that the attackers can access them easily, and security is a very important subject for us for this reason. And also, an important thing to know is that security issues show up every single day. And even if you are not working on 300 packages per build, you do not want to manually look up for security issues every single day. Now, when we start talking about security issues, there are a few abbreviations that you should know, and let's go through them rapidly. The first one is CVE, Common Vulnerabilities and Exposures. It is a database. It contains unique IDs to issues. For example, we may expect to have soon in the future a CVE 2022 12345. Then we have NVD, National Vulnerability Database, a database that contains the information, the IDs of CVEs, with some additional information like which version of the software is affected, where are the fixes, links to vendor information about the issue and the fixes, and all useful information related to that issue. And then finally, we have CPE, Common Platform Enumeration, is a standard to describe a product or a software project in a unique way so that we can identify them. And this is the way NVD uses to identify which issue affects which program. Let's have a look now about an example of an issue in the NVD database. At the beginning, you can see the number, and then you do have the description, which writes how the issue behaves, and sometimes a little bit more, information about the version. Then you do have the severity analysis, which tells us how serious it is using the base score and the vector that gives a little more information about that. If you are more interested, we can discuss that later. And then you have references into the tools, solutions, patches. In this case, we do have a chance to have an actual link to the patch and to the commit in the libdecrypt repository containing the patch. It's pretty easy to figure out the patch. And then at the end, we have which version is affected. A few notes from the practice in the security field. CVE isn't the only format that exists. There are some others, but it's the most popular one. So it makes sense to start scanning from this format. But if an issue doesn't have a CVE, doesn't mean it isn't a security issue. Basically, to get a CVE number, someone has to apply for one. Imagine that you are a developer fixing a buffer overflow in your application or library. This buffer overflow could maybe be exploited by someone, but it will get a CVE only if you apply for one. Most people don't. So quite many bug fixes that could be exploited do not have CVEs. Then in the NVD databases, we have quite often mismatches for the product names. We have abbreviated or not abbreviated project names. We have the distro name used as the only product name and not the upstream project. And we have a lot of movement just after the issue becomes public. Because, for example, we may have a backport to a stable REIS that is not yet included into the affected or non-affected products. The databases are useful, but they do have their limitations. What do we have in Yocto and embedded by default? We do have CVCheck. It checks every single package in the NVD database, gets a list of issues, and then verifies if this version does contain this vulnerability or not. Please remember that this tool works only on package version. It's not doing any kind of a source scanning, just looking up the version number. Developers with CVCheck have a way to mark that they have added a fix. So we have a basic package that has an issue, and then we add a patch for this issue. And then we mark that we are no longer having this issue. We may have also a situation that a certain security problem affects only certain platforms, and if we are not building on that platform, it doesn't affect us at all. And the final thing, CVCheck lists a package only it has at least one vulnerability. It may be fixed or not fixed, but it has to be at least one. So what we have found out using CVCheck. First, the list of issues differs from the official Yocto builds to our builds. And that is pretty obvious because we do have different layers and we do have different packages. So we have to rerun to get our own results. And then around half of the packages is not on the issues list. And we were wondering what's going on here. Either those packages have no vulnerabilities or we do have a package or version mismatches. Another interesting thing is that about half of all the issues that we have is in the Linux kernel. This is probably a research topic on its own, but it could be because of the focus bias and the fact that people tend to report issues in the Linux kernel and get CVEs for them, and maybe less for other libraries and products. Then we have added some additional passes to CVCheck. I would like to talk about the coverage. It's just an extension of CVCheck, and it's showing if we do have any CVs in the database for the specific product. It makes it easier to find mismatches in the database. As a result, we are finding mismatches and we are fixing them, and we could review the packages that we have that do not have any CVs and find out what the reasons are. And now some examples of issues we have fixed. Python had recently an issue, and the original analysis says the issue affects the versions 3.8.0 to 3.9.5, and it's fixed in 3.9.5. But the database at the moment when we are running the tests hasn't been updated to say that the fix has been backported to 3.8.12. What we did, we sent an email to the people taking care of the NVIDIA database, fixed, and one less issue to worry about. If you're interested, I give you a link to the issue and you can see the history of the modifications. Then something a little bit more complicated, 2 issues in libdecrypt. Those 2 issues were reported in one research paper, which is probably not the easiest way to do it. And then there was a misunderstanding between the developers and the researchers about which CVE is which. So developers developed the fix on their own, and someone updated the CV descriptions, and unfortunately they were not in line. So the developers fixed one issue without putting a CV number in it, and they put a CV number in another fix, but unfortunately it was not matching the description of the issue. So what we have done in Yocto is to fix the whole story, and you can see our description of the issue in a commit to Open Embedded. We have a lot of ideas for further tools and how to help the community when scanning for security issues. The first thing we want to have is a machine-readable format for the issues. Currently, the format is text-based. It's easy to read, but less easy to process automatically. Then we would like to detect copied code and run security checks on them. This is especially important when some project includes some libraries, and we'd like to know if the libraries they include have issues or not, and if we need to update those libraries. And then we would like to be able to scan upstream branches for all fixes in the stable releases. Because as I've told you, a security issue does not always have a CVE, and we may be interested to look up at all fixes that the developers backport to stable branches. And finally, all that is also related to the SBOM generation if you are in the subject. Takeaways from us. You can check for known issues in the packages you use in Yocto. We are using the source form, so it's easy for us, relatively, of course. Still, manual verification is needed because there could be some issues in the databases or in applying patches. And scanning is a tool, but it's just the beginning. At Neuro, we are also doing hardening to avoid issues from showing up, having impact, and we plan for more tools to add in the future. A few links if you're interested in the Neuro project. And thank you for your attention, and let's discuss in the question and answer section. Hello, everyone, and welcome into the questions and answer part. I'm going to answer the questions that are there in the chat. I can see that they already got answers inside the chat, but I will add a few things. The first question we had is, how do you apply for a CV? And it's a very important question. You have found an issue. So if your organization is already an approved one and is handling CV numbers, you should probably know about it. If you are a project under Eclipse or Apache, those organizations are approved ones. And there is a few hundred with the latest data of approved organizations. So if you are under one of those organizations, you apply directly to your organization. And you should have a contact information somewhere available. Then if you are not, if you are an independent project, for example, you ask directly from the CVE.org. This is a new website. They are doing an update and there are new functionalities on the website. So previously it was a Mitra website. Now it's just CVE.org, and you will find the right form on how to apply for a CVE number. And then the second question we had was about how you become an approved organization. Also, we got an answer, and also the same website, cve.org, and you will have the form to fill and a little administrative procedure to follow. From what I know, they are looking forward into welcoming new organizations as approved organizations. So if you have a doubt if you should be one, then do apply. The procedure is pretty simple and you will be able to do it, and they handle the vulnerabilities in your product on your own. Do we have any other questions? I can see that we exactly have the form given in the chat, so you can find all the information in the chat on how to do it. If there are any other questions, I will maybe confirm you yet again that for a CV you have to apply for one. If you find an issue in the vulnerability database, go forward, send a message for them to fix it. My typical experience is a fix in 24 hours. So if you find something, just tell them. You don't have to do any workarounds, and you will help every other product or project using the same type of software to have the correct data. With the vulnerability list, we all help each other, so it's very easy to apply and to ask for modifications. Thank you all, and have a good afternoon or morning or evening, depending on the time zone.